So today we're going to do a couple things. We're first going to learn about a new form for quadratic functions. We've talked about standard form pretty much the entire time. We're going to learn about something called vertex form, and then we're going to continue on with some of the stuff about transformations. You know, the reflections, the translations, the dilations, all of that stuff. All right, so first, vertex form. So not so much a definition. I'm just going to kind of write down exactly what the vertex form is. So looks like this. Y equals, we've got some sort of coefficient A, and then in parentheses, x minus h squared, and then plus k. So we've got a handful of different things that we can see from this form, because there are reasons that we like standard form and there are reasons that we like vertex form. One of the reasons that we like vertex form is because the vertex is given to us. The vertex is h comma k. So one thing I want you to notice here is that this is a negative h, so our h value that we pull for the vertex is always the opposite of this. I will explain that when we have actual numbers to work with. And then A actually does the exact same thing that A does in the standard form. It tells us whether the graph flips upward or downward and just how wide it is and things like that. All right, so first we're going to practice writing these in vertex form. It's very, very similar to the process of completing the square. All right, so for completing the square, what we're going to do is we're going to first try to figure out how we can turn this part of the equation into a perfect square trinomial. And so we're still going to do that process of taking the middle term, cutting it in half, squaring it. Here's the thing though, is that we have a y on the other side. Any form that you're in, standard form, vertex form, whatever, the y has to remain alone. So rather than moving this 6 to the other side, we're just kind of going to move the 6 out of the way, if that makes sense. So we're going to have y equals x squared plus 4x, and then like I said, we're just going to kind of move the 6 out of the way, and we are going to focus on this area right here and try to figure out what constant we need in order to complete the square. All right, so we do the same process that we had done when we were in the completing the square section. We take the middle term, which is 4, and we take that middle term, we cut it in half, and we square it. Okay, so a little side work. We take that middle term of 4, cut it in half, and that gives us 2, and then we square it, and of course 2 squared gives us 4. So that process that we take means we are going to add 4 right here. So 4 is the number that is going to complete the square. Normally, we would add 4 over to the other side, but like I said, we don't want to put anything here but a y. So what we do to balance, I guess, balance this addition of 4 that we just did, we subtract 4 once we're done. So on the same side, we've just added 4 and subtracted 4. So technically nothing has changed, but we're working on getting it in the form that we need. So y equals, back to this piece right here. Again, when you're completing the square, we remember how it works to simplify this down and write it as a binomial squared. So we're always going to have a binomial squared like this. You're going to have an x, and then the piece that goes in here is half of this coefficient. So half of the positive 4 is a positive 2. And if for some reason you ever don't believe me, you can take the x plus 2 squared, write x plus 2 times x plus 2, FOIL it out, and I promise you, you will get this. And then we can simplify the positive 6 minus 4, and that gives us a positive 2. So this is our vertex form right here. This is totally simplified down. Now, this equation is the exact same as this equation. If I graphed them, I'd get the same thing. This form, though, is standard form. It tells me what my y-intercept is, which is good. This form is vertex form. It tells me where my vertex is, which is kind of why I like that. One thing I want to point out to you. This term right here ends up being the x-coordinate of the vertex. So the vertex ends up being, notice this form. H is the opposite of what I see in here. So if there's a negative h in here, the vertex is h. Since there's a positive 2 in here, the x-coordinate of the vertex is a negative 2. And then you take exactly what number is right here. So the y-coordinate is 2. All right, and what I wanted to point out is this is our vertex. What I want to point out is the vertex formula. Remember, the vertex formula is negative b over 2a. This is not a necessary part of the notes. I just want to point something out to you. So negative b over 2a gives us negative b, which is 4, and then over 2 times a, which is 2. And so the vertex ends up being a negative 2. And so we could take this, we could simplify it down, we could plug it into this equation, we would get 2. But doing this process is actually very, very quick and easy. So the answer that we're looking for here is just the new equation in vertex form. This is just a little side work to show you how it works. Okay, next one, part B. This is something that we need to pay attention to and be careful with, is that 2. So we did this when we were completing the square. If there was ever a constant there other than just a 1, we had to divide it out. Well, things are a little bit different because I have a y on this side, not just a 0. And so rather than dividing it out, I am going to factor it out. So I'm going to factor out a 2, and then I'm going to write what's left in parentheses. So when I factor out a 2 here, I am left with just an x squared. When I factor out a 2 here, I am left with a negative 6x. And when I factor out a 2 here, I am left with a lovely 17 halves. You can do 17 halves, you can do 8.5, 8.5. I just always leave fractions, and I'll explain why as we're going down through the problem. Okay, so next thing that we are going to do, this 17, we need to move that actually to the outside, so I probably shouldn't have factored that out to begin with. Let's forget that I even did that. We are going to focus on this part right here, just like we did up above. So what we're going to do is we're going to move the 17 out of the way, just like we did in our first step up here. So we know the 17 is not what we need, so we are just going to move that out of the way until we need to deal with it later, just like we did with the 6 up here. I apologize for this step. What we're going to do is we are going to focus on this part right here. That part is not supposed to have anything attached to the x squared. So in just these terms, I'm going to factor out a 2. So y equals, I'm going to factor out a 2. I will have an x squared minus 6x, just like I did up above. Leave a little space because I am going to have to complete the square inside the parentheses. And then the positive 17 is just hanging out on the outside. It wasn't the constant that we needed, so we didn't need to factor out a 2. Okay, so next thing, inside the parentheses, we are going to complete the square. All right, so we want to look at that negative 6, and we're going to do the same process that we did up above with 4. We are going to take that negative 6, we're going to cut it in half and square it. So start with the negative 6, cut it in half, that gives us negative 3, and then square it. Negative 3 times negative 3 is positive 9. And so I am going to add 9 right here. And now with these ones, the ones where we factored out a 2 or something like it, you need to be super, super, super careful, because what we actually just added to the right-hand side was an 18. We have 2x squared minus 12x plus 18. So we actually need to balance that addition of 18 with the subtraction of 18. All right, so be super, super, super careful with those anytime that you've got a constant outside of parentheses here. And I'll explain that again. We didn't really just add a 9. We added a 9 inside of a set of parentheses. Outside the set of parentheses was a 2. So if I redistribute that 2, what I actually have is 2x squared minus 12x plus 18. So what I really added was an 18, so I have to balance it by subtracting 18. All right, so let's jump to the next step. Y equals, I leave my 2 right here, right where it is. I am going to simplify this perfect square trinomial down to a binomial squared. So again, just like the pattern up above, the number that goes in here is half of this middle term. So half of a negative 6 is a negative 3. If you ever did not believe me, you could FOIL that out again, and you'd see that you get x squared minus 6x plus 9. And then this constant simplifies to a negative 1, positive 17 and a negative 18. So that is my equation in vertex form. Okay, so we are going to work with this form a little bit. We're going to talk about some transformations. So we are going to work with the vertex and then one additional point, and that's really all you need. And we actually did that on our last quiz. We had the vertex and we had the y-intercept. And when we had the y-intercept, we just plotted another point on the other side. So let's figure out this little standard, this multiple choice problem. Here's our vertex right here. Our vertex appears to be, oh, they actually gave us a point right there. Our vertex is negative 1, negative 2. So the 2, if we look in standard form, the negative 2 should be right here on the end. So it's one of these. It is not going to be one of these, because the negative 2, the y value, should be exactly what you see on the end here, not the opposite. So it's not one of these. And then negative 1, you should actually have the opposite of that inside parentheses. So these both have a plus 1, which is perfect. So now we need to figure out if this one has a 3/5 or a 5/3. Okay? So what we are going to do is we're going to plug in the negative 4/13 and see which one it works out to be. So you can pick really either one that you want. You could pick this one, guess B, guess C. So let's say that we guess that it's B. So let's plug in this other point, this negative 4/13, and see if equation B turns out to be true. If equation B turns out true, then our answer is B. If equation B turns out false, then our answer is C. So let's plug in. So y, we're going to plug in a 13, equals 3/5, and then in parentheses, -4 plus 1 squared minus 2. Okay, so here's what we get. We want to know if this is actually true, if this right-hand side actually does equal 13. So does it equal 13? Let's see. 3/5 times -4 plus 1 is -3. Squared gives me 9 minus 2. All right, let's see. 3/5 of 9 is going to be some messy fraction, 27/5 minus 2. I am thinking that this ugly fraction minus 2 is not going to turn out to give us a whole number. So this is not the equation, which means this is the equation. All right, we're going to spend the rest of our time on transformations of quadratic graphs. All right, so we've got different translations that we could take: horizontal translations, vertical translations, reflections, and dilations. And since we already learned about all of these transformations, we're going to work through them pretty quickly. And so we've got this horizontal translation. This is our standard form right here. So we could add an A, an H, a K. Horizontal translation is H. It's given by H. Whatever this value of H is, it translates our original parabola. So we move H units to the right. If H is positive, a value that's greater than 0, we move H units to the left if H is negative. Okay, and pay attention here that H is something that's subtracted, and so we actually have to go with the opposite. Okay, so say that here's our original. These translations, these left and right translations, would move us over here. So say we had like a positive H, and it would translate our parabola over here. Something like that would be a horizontal translation. And so it would move the x value of the vertex over to the left or maybe over to the right. Vertical translation would be up or down. This is given by the value of k, the value that's hanging out on the end here. So if you have some sort of number there, it's going to be a vertical translation. It's going to move your graph up or down. Okay, so it's going to be k units up if k is positive. And then it would be k units down if k is negative. Okay, so let me give you an example here. So again, say we start with the original parabola, just like this. Let's do a negative k this time. Say we move down to here. Negative k, our parabola would get moved down like that. So let's say that that is a negative value of k. Okay, so that's a vertical translation. It moves the y coordinate of our vertex either up or down. A reflection. Reflection is given by A, if A is positive or if A is negative. Okay, so it's not really a reflection per se, but it tells us whether our graph opens up or down. So if A is positive, if the coefficient in front here is a positive number, and these are the same rules as standard form, the graph opens up. If A is negative, the graph opens down. Okay, so the original ones I've been drawing have been the ones that open up. So that'll be a value of A that is greater than 0. Or if my graph flips upside down, like this, that would be a value of A that is less than 0. Okay, so two different possibilities for kind of the shape of the graph. And the last thing is the dilation. Remember, the dilation is either a stretch or a compression. And so that actually is also given by A. The reflection is given by the sign of A, just whether it's positive or negative. The dilation is given by the actual value of A. Okay, so if the absolute value of A is greater than 1, so you know, if it's a positive 2 or it's a negative 3 or a positive 4 or whatever, the graph is stretched vertically. And we saw examples like that a couple chapters ago. Remember what a vertical stretch does is it pulls it up and down. It actually makes it skinnier. And then if the absolute value of A is somewhere between 0 and 1, like if it's a fraction, the graph will be compressed vertically. Okay, so let's give a couple of examples here. So here's the original. So if I give you a positive value of a value of a that's greater than 1, it will stretch it like this. Okay, so that would be where the absolute value of a is greater than 1. Or if I give you something where it's like a fraction, then it would be compressed, which would make it this really wide arched parabola. Okay, so this would fall in the second category where the absolute value of a is between 0 and 1. All right, so just some sample values there. We're going to use that to give some quick sketches of these graphs. So we want to look in the standard form here. So our vertex form is a times x minus h squared plus k. Okay, so here's what we've got. H is 3. Okay, so h equals 3 when we're looking at this form. A, there's really just a 1 here technically, and then k is this number on the end, which is a negative 2. Be very, very careful between the h and the k. Here, h is subtracted, and so here we're subtracting 3, which means h is 3. Here we add k, so here we're technically adding a negative 2. Okay, so what this does, so these are all translations from the original parabola. This means that our graph is going to move 3 units to the right. This means that our graph is right side up and actually does not get stretched or compressed at all. 1 is kind of what the original parabola has, so that doesn't cause any changes. This one is going to move 2 units down, a negative 2. So it actually gives us a new vertex. Gives us a new vertex of positive 3, negative 2. Okay, so we're going to give just a quick sketch. The important thing is to get the exact vertex and then kind of the general shape of the graph. So 1, 2, 3, 1, 2, so we've got that as our new vertex. And then because this A is positive, it tells us that our graph opens upward. And so basically, as long as you have the right vertex and the right shape, I will be content with a graph that looks kind of as easy, as simple as that. All right, next page. Got one more of these. Okay, so we are going to write A. So A is 0.25, aka 1/4, however you want to look at it. H, remember, because H is the opposite of whatever you've gotten here. So H is a negative 1. And then K, there's nothing on the outside here, so we're just going to say that K is 0. Even if one of those values is 0 or 1, whatever you're used to, I still want you to write it down, and then we kind of want to comment on it. So this is, it's flipped upward because it's positive, but it is going to be compressed, and it's going to be quite a bit compressed because that is a value of 1/4. This negative 1 means we are going to move to the left 1 unit. And this value doesn't change. So this is no change that we see here. We're not going to move up or down. We're still going to be right on the x-axis. Okay, so let's give a quick sketch of that. So my vertex, if we make a quick note here, my vertex is the value of h and then the value of k. So h is a negative 1, k is 0. So my vertex is sitting right on the x-axis. It's right here. So I start with that point, and then my parabola opens up and down because this is positive, but it's very much compressed because of the 1/4. So it's going to look something like this, like a very, very wide parabola. Okay, so that's it.